Everything in the world is made up of atoms. Your food, your car, your bed, your phone. Even you contains 7 octillion, that's 7 billion, or well, this rather large number. And as you would expect, they are really, really, really small. So tiny in fact that a grain of sand contains around 43 quintillion atoms, and they each have a diameter of around 10 to the minus 10 meters. Good luck trying to count them. As small as they are, each atom has distinct features. They each contain a piece called the nucleus at their centre, which contains particles called protons and neutrons, as well as shells on the outside, which contain particles called electrons. Surprisingly, the nucleus is really small relative to the size of the atom. For instance, if this P represents the nucleus, the outer edge of the atom would be almost a kilometre away. Inside the nucleus, the number of protons determines the element of the atom. Hydrogen has 1, iron has 26, and gold has 79 protons, with organocin being the highest element discovered so far, with 118 protons. Each proton has a positive +1 charge and a relative mass of 1. The atomic number of an atom is simply how many protons it contains, and in fact, the periodic table orders elements based on this number. Now, let's be clear. When we refer to the mass of a subatomic particle, like a proton, we aren't referring to it in grams or kilograms. In fact, protons actually have a mass of about 1.67 times 10 to the minus 27 kilograms, which is this rather small number. However, we say that protons have a relative mass of 1, just to keep things simple, and then compare this with other small particles. Neutrons also each have a relative mass of 1, but as their name suggests, have no charge, or as we say, are neutral. On the outside the nucleus, electrons sit in energy shells around the atom. Each electron has a -1 charge and a relative mass of just 0.0005. Really, really small. Thankfully, calculating the mass, or the atomic mass of an atom I should say, is relatively straightforward. Because each proton and neutron have a relative mass of 1, we just have to add the total number of protons and neutrons together. But hang on, what about the electrons? Well, because they are so small, their overall mass is negligible and so isn't usually included. In any atom, the number of electrons is equal to the number of protons, making them always electrically neutral. Because protons and electrons have opposite charges, the electrons are attracted to the protons in the nucleus by an electrostatic force, the same force used to attract this can to this rod, and the same force that causes your hair to stick to a balloon when you rub them together, which stops the electrons from flying away. Sometimes, however, atoms can lose or gain electrons to become electrically charged and form ions. We'll discuss this in a later video. But if atoms are so small, how do they make up your food, your car, your bed, your phone, or even you? Put simply, lots of them join together and can even bond with other atoms of different elements to form more complex structures called compounds. But that's a topic for another day. Remember, if you enjoy this video, be sure to like, subscribe and press the notification bell, as well as check out our other videos and practice your knowledge with our custom-made worksheets at workedexample.xyz. Thank you for watching, and most importantly, stay safe.